Everything is fine or not? First, I will check, then start my class. Everything is fine or not? Yes, everything is fine. So today we study the formation of differential equation. Okay. So first of all, so today we study the formation of differential equation. It is a fundamental topic in suppose that differential calculus or mathematical science. Okay. So the main idea is simple. We form a differential equation by eliminating some arbitrary constant or arbitrary function from a given relation. Okay. So the process just convert a family of curve into a mathematical equation involving some derivative. Okay. So mathematically extremely used in something like physics, engineering, or mathematical modeling. So basic concepts, suppose you have some relation involving some independent variable like this. Actually, I'm trying to write this step. Then I'm show you which slide I have. Okay, I am on 8 slide. Then move on. The next part. Yeah, here. So basic concept behind this. Suppose we have some relation involving independent variable. You know the independent variable before I am teach this already. I am teach you. Okay. So basic concept like this. Suppose we have a relation involving independent variable x. Okay, and dependent variable y. And an arbitrary constant. Suppose that the equation, suppose that the relation like this, if here x is our independent variable, y is our dependent variable, add some arbitrary constant like this, c2 equal to 0. So here x is our independent variable, y is our dependent variable. Okay, and the C2 terms like this is our n arbitrary constant. So the relation, our goal is to eliminate this constant and obtain a relation involving only x, y, and derivative of y with respect to x. Okay, so so first of all, our goal is what? First, in a step, there is something steps for their solving many steps here. First of all, I will show you something like this. So first, our goal is what? Our goal is eliminate this constant. Okay. Our goal is first eliminate this constant, and obtain a relation involving only x comma y, and derivative of y with respect to x. Okay. So rules say that if a relation contain an arbitrary constant, okay, if a rule say that relation contains an arbitrary constant, okay, then differentiate it n times. Okay, then these are the basic concept. Then we move on steps to formation of differential equation. First of all, start with given equation containing arbitrary constant, then differentiate with respect to independent variable, and repeat differentiation equally to the number of constant. Okay. Then in fourth step, eliminate the constant from all equation over 10. And then final steps relation is required for differential equation. So these are the basic idea uh, which we have to find something. First of all, I'll show you how to formation with one arbitrary constant. Okay, let's take one example here. So I will show you now. First of all, I am show you the steps here, something like this. Then I will proceed on what I'm trying to say you. Okay, I am on 8th slide. Okay, so here something the complement primitive general particular solution is similar solution. Here something containing an independent arbitrary constant. These are the basic which will I have already told you in our previous classes. Okay, so my aim is to find some arbitrary constant. So how to uh, just I am show you what I'm trying to say you. Write the equation of given working rule to form a differential equation for the given equation in x and y. And here is the arbitrary and arbitrary constant. So first step is write the equation of the given family of curve, and in second step differentiate the equation. Take in here a step first, then differentiate again and n times so as to get an additional equation containing an arbitrary constant and derivatives. And in third step, eliminate an arbitrary constant from n plus 1 equation, obtain the steps first and second. So these are the required differential equation involving a differentiate derivative of nth order. Okay. So now my first aim is to explain you how to deal with these steps. Okay. So I'm take one example to show you where I am. Yeah, here. So these are the basic steps to the formation of formation of differential equation. So take a one example, which will I will show you to the formation with one arbitrary constant. So let's start with this. Yeah, here is some formation with one arbitrary constant. So how the formation is like this. To take a one example here, take y is equal to cx square. Okay, differentiate with respect to x. So dy by dx, which is equal to 2cx like this. And from original equation here, c is equal to the value is y upon x square. Substitute into the derivative. Okay, so dy upon dx which is equal to 2x dot y upon x square which is equal to 2y upon x. So final differential equation comes like this now, dy upon dx which is equal to 2y. Okay, now uh, I have only take a one arbitrary constant. So in the next steps, in next example, take a two arbitrary constant. Okay, formation with two arbitrary constant. So here in next example, here I am take formation with two arbitrary constant. Okay, so here example number two, take y is equal to c1 e to the power x plus c2 e to the power minus x. Okay, so first of all differentiate this, then you get c1 e to the power x minus c2 e to the power minus x. Again differentiate again, double derivative, so c1 e to the power x plus c2 e to the power minus x. So observing that the right hand side of the second derivative is exactly original equation. So here y double derivative which is equal to y. Okay. So final differential equation like this now, y double derivative minus y which is equal to 0. Now in next step, you the formation from a family of curve. Okay. So in formation from a family of curve. Now take a this as example number 3. Okay, so here family of circle centered at origin. If a family circle centered at origin, then their equation like this plus y square which is equal to a square. Here a is the arbitrary constant. So differentiate here, when you differentiate this, then you get 2x plus 2y dy upon dx which is equal to 0 because a square is our constant term. So now simplify this. When you simplify this, you get x plus y dy upon dx which is equal to 0. So this is the differential equation representing all circuits centered at the origin. Okay. Now the next part is formation with arbitrary function. Okay. These are the formation from a family of curve. Now next part is formation with arbitrary constant. Okay, arbitrary function, sorry. Sometimes this relation contains an arbitrary function rather than constant. So take one example here. Okay, now in this relation contains arbitrary function rather than constant. Okay, so here example like this, y is equal to fx. Now differentiate this, so you will get y dash which is equal to f dash x now. and their double derivative look like this, f double derivative like this, x. So since fx is equal to y, okay, the differential equation can be expressed directly. That is, if function f is not specified, okay, the function f is not specified, we often end with a relation like y double dash, which is equal to f double dash x. But to eliminate f, okay, so additional constant condition are need for pure elimination. For pure elimination, if f is arbitrary, then if f is arbitrary, the differential equation is simplify d2i upon dx square, which is equal to arbitrary. Okay. However, in a standard problem, the form of f is given implicitly. Okay. So next one is our order and degree of differential equation. Now I come to my topic. These are the basic how you format with some constant, some arbitrary function with respect to dependent. There here is the formation from a family of curve. Here the formation with arbitrary function, and here is we take a one two arbitrary constant, then this formation. Now formation with one arbitrary constant. So come to the main part. Okay, in page number 8, I'll show you some more example. Now formation of differential equation. These are the working rule. Okay, so given from family of curve. Here is one example which is asked in our IS exam prelims 2002. Okay, so the question say that find the differential equation of all circle which pass through the origin and whose center are on the x-axis. First, maybe you understand the last one. You say that you see that here x square plus y square, which is equal to a square, like family of curves. So centered at origin. Now here, first of all, in solution number A, so that you know the equation of circle passing through the origin is center on the x-axis. When the center on the x-axis, then equation like this, because you know the standard format of circle like this, na x square plus y square plus 2gx plus 2fy plus c equal to 0, like this, na. So something like this. So here only term the origin, through the origin and whose center are on the x-axis. Then so being with arbitrary constant, then differentiate it with respect to it, and you get 2x plus 2y dy upon dx plus 2g equal to 0. And then again from first 2gx, which is equal to x square plus y square, na? So that 2g, which is equal to minus x square, sorry, in bracket x square plus y square upon my x. Okay. So substitute for 2g from t to 3 into. So you get what? You get this. Okay. And or when you solve this, then you find this. 2xy dy upon dx plus x square minus y square equal to 0. Now one more question asking the type of arbitrary constant like this. Find the differential equation family of curve which is equal to y is equal to a to the power x a plus cos x plus b sin x. Okay, a and b are two are arbitrary constant here. So these are the equation, and when you differentiate this, when you differentiate now differentiate first. So e to the power x, and next one, you know the how to differentiation of this type of given arbitrary constant or given any equation. So the differential equation of the family of curve like this. So when you differentiate this, then you get y dash which is equal to e to the power x minus a sin x plus b cos x. Okay. Now next part is differentiate again. When you differentiate again, then uh, you get y dash which is equal to y for the original equation. Then he eliminate a from b, a and b from first and two. Then you get y double dash minus 2y dash plus 2y which is equal to 0. I know the this steps is very shortest part to explain you, but you understand it. Okay. Now next part is here, the next question like this, which I already asked in 1992. The equation is the by eliminating the constant a and b obtain the differential equation for which xy which is equal to e to the power x b e to the power minus x plus x square is solution. So first of all, you differentiate with respect to x, and here is the xy now. Then when you differentiate this, then you get the equation number 2. Again last step is like this, so try at your home. Okay. The next part is here also equation of the all circle of radius of a. So the equation of all circle of radius a which is given as x minus h square plus y minus k square which is equal to a square like this. So already I told you this type of problem. So this is also you understand better. Next part like this now I'm tell you the three parameter family of curve. So these are the three parameter family of curve, which is the standard equation. I think I told you related to the circle. So here where a b c are parameter, then you differentiate this and you will get this. Okay. So my next task is I will teach you this topic in our next class. This lecture. Actually, the whole lecture, here is some quick example I am show you. So important type, for example, like elimination of constant, okay, formation from geometrical families, line, circle, parabola, ellipse, formation using arbitrary constant. These are the important type for exam. Okay, I'm write to you. I'm write this. Okay, so important types for exam. First one is elimination of constant. Okay. Second one is formation from geometric family like line, circle, parabola, okay, and then ellipse. This type of I think you understand this. These are important type for exam. Okay. First one is elimination of constant type problem. Second one is formation from geometric family like line, circle, parabola, or ellipse. And third one is formation using arbitrary functions. Fourth is formation of PDE by eliminating arbitrary function. And fifth is last, which is optional many times, but it is very important, like orthogonal trajectories. Okay. So common mistake for all students like this not differentiate the correct number of times. Okay. Algebraic error while eliminating constant. So must we understand how to fix these mistakes. Okay. So now I have one more example for practice. Okay. Here is one problem. First one is differential equation like this: y is equal to c1 cos x plus c2 sin x. So first differentiate this. Okay. In first step, you when you differentiate this, you get c1 sin x plus c2 cos x. After again you differentiate again, and here c1 cos x minus c2 sin x. Okay. Now take common part, c1 cos x plus c2 sin x. Okay. So here you see that this is also in y. So y, and your final answer is y double dash plus y, which is equal to 0. So these are the type of formation of differential equation. Okay. Actually, their application may be differential equation formed in this manner and used in many ways. Suppose that in motion of particles in physics, in electrical circuits in engineering, heat and waves, signal processing, mathematical modeling in biology, economics, and control system. So the whole part in this lecture we study, first one is a differential equation is formed by eliminating arbitrary constant function. Okay. Second part, differentiate as many times as the number of constant. And next step, eliminate constant to obtain the relational involving derivatives. And next step, identify order and degree correctly. You know the better way in previous class already I have told you. And next one is practice different curve families of for the your exam. So I hope you understand this. And next time, I will teach you the Roskian part. For no, Roskian part is nothing but I think lecture is too short. Here, the next part is our Roskian. Roskian is nothing but you take the derivative then up to n times. Okay. Linearly independent and independent set for actually I told you today. Okay. So here is some definition related to linearly dependent and independent set of function. So now the definition so that n function like this y1x, y2x up to ynx are linearly dependent if there exists a constant which is not all zero such that c1y1 plus c2y2 plus cnyn which is equal to 0. And however, identify first multiply this, okay? And when you get some value which is equal to 0, then said that these are the linearly independent. So y1, y2, yn are said to be linearly independent. Here is some defined concept of linear dependent and independence. And so these are all really example. I will show you in the next class. Okay. I hope you understand this. So thank you. Good night. See you in next class. Okay. Tata bye bye. So thanks for watching this video. Okay.